Hello students, welcome to Dr. Sharab's classes. So as you know, this video is dedicated to this UPSC Mathematics Paper 1 because we are solving in the first few videos, we are solving this Maths Paper 1 of this UPSC Civil Service optional paper and we are solving this paper of 2021, right? So in the previous video I have checked this question number 5C. So in this we have the question number 5D. So let's solve this question. Okay, so what the question is saying: if a planet which revolves around the sun in a circular orbit is suddenly stopped in its orbit, then find the time in which it would fall into the sun. Now also find the ratio of the falling time to the period of revolution of the planet. So ratio of the falling time to the period of revolution of the planet, you have to find these two things actually. This is question number 5D of section B. So here you can see a picture. So suppose this is the P is the planet and S is the sun, and they have a radius A, okay, between them, this P and S, okay, of radius A. Now the thing is that, so we have described this, okay. Let a planet describing a circular path of a radius A, okay, from the picture you can see center S, that is the sun. This be stopped at the point P, so this is the P of its path. So then it will move towards S. So then it will begin to move towards the point S, that is the center, along the straight line PS, right, under the acceleration. So the acceleration is mu by distance square. So this is the acceleration, right? So let us take this R be the position, this small r, let small r be the position of the planet at time, suppose t, okay, such that from the figure you can see that SQ is equal to R, this smaller, okay. So then the acceleration at Q, so it will be mu by R square, right, and it will be directed towards which, this S, that is the center. So directed towards S, okay. Now the equation of the motion of the planet at point Q, equation of motion of the planet at point Q, we have this V dV dr minus mu by R square. Now why this minus? Why this negative sign? This negative sign is taken as the acceleration at Q is in the direction of R, okay. So the acceleration is decreasing, okay, this direction of R, and the acceleration is decreasing. So this is due to this, we have taken this minus over here, minus mu by R square. So we can simplify it writing this in this, so B v of dv minus mu by r square dr. Okay, so now integrating both sides, we find it will be v square by 2, and it is simply mu by r plus a. Now what is a? A is simply a constant. Okay, a is nothing but a constant. Now at point P, so this is the position at point P, we have this SP equal to a, that is the radius, and then v equal to 0. Why v is equal to 0? The planet begins to move along PS with 0 velocity at P. So the v is 0 at P because it is suddenly stopped over there. So we can write that at P, at this point P, r is equal to SP equal to a, that is the radius, and v is equal to 0 because 0 velocity at point P, right? Now we have this from v square, we have this 0, so it is mu by r, in r place we will write a plus a. So we have a, that is a constant of integration, as minus of mu by a. Okay, minus of mu by a. So here we will put the equation, this value of a, so it will be v square by 2 mu by r minus mu by a. So simplifying this, if we have this mu, take it outside, a minus r by ar, right? So what will be v? So v, we know that v is equal to dr dt, so we can write v as equal to root over, so we have minus root over 2 mu by a multiplied by root over of a minus r by r. So again, why this negative sign? This negative sign is taken because r decreases as t increases. Okay, now what is the dt? From here you can find the dt. So dt, we have to find that t over here, so dt is nothing but this minus, it is a by 2 mu, right? It is a by 2 mu multiplied by this r by a minus r of dt. Simple. Sorry, there is dt, or there is it will be dr, right? This is not dt, this is dr. So dt we can find. So this is, let us take this equation 1. So if t is the time taken by the planet, so t1, time taken by the planet, okay, from P to S, then integrating 1, we will have 0 to t1 dt, then we have this root over a by 2 mu, okay, a by 2 mu, obviously minus is there, and we have this r of r equal to a to 0, right, into root over r by a minus r dr. Okay, so now here we have this t1 on the left hand side, that is t1, so which is equal to a by 2 mu, and the integral you can do, this is minus is there, so you can write this 0 to pi minus 2, this pi by 2. How we will do that? We'll look into that. So root over of r is equal to a cos square theta by a minus a cos square theta, that is 2a cos theta sin theta d theta. So what we have done, we have taken that putting of r equal to a cos square theta. Okay, if we put r equal to a cos square theta, so we have this dr is equal to, so it will be equal to r of cos square theta, so dr equal to minus of 2a cos theta sin theta d theta. So we have put it over here. Okay, now simplifying this, we have this a, so we have a over here, and root over of a by 2 mu. So this is going to be 0 to pi by 2. It will be 2 cos square theta d theta, or it is a, then root over a by 2 pi, okay, integral 0 to pi by 2 1 plus cos 2 theta d theta, right? Now again we can write this a of root over a by 2 pi, okay, this is theta plus half of sin 2 theta it will be, and we have the integral from 0 to pi by 2. So solving this, we will have this pi of a to the power 3 by 2 by 2 into 2 pi. So that is the time t1 that is taken by the planet from P to S, right? Now the time period t, the capital T of the planet revolution, okay, time period capital T for the planet revolution. So what will be the planet T? So it is given by T is equal to 2 pi a to the power 3 by 2 by mu. So this is mu. Okay, so we have to find the ratio. So the ratio is given by t1 by t. Okay, so t1 we have this pi of a cube, so this it will cancel out this one, and 2 will cancel out. Okay, so we have this t1 by capital T, so it will be 1 by 4 root 2, right? Or we can write this as root 2 by 8. So from here we can write this t1 is equal to root 2 by 8 capital T. Okay, so this is the answer. So the time taken by the planet. So how to write the answer? So the time taken by the planet from P to S, okay, is root over 2 by 8 times the period of the planet's revolution. And we have already find the answer of the t1, that is the time taken by the, okay, so this is the time taken by the planet from traveling from P to S, so that is pi of a to the power 3 by 2 to root 2 mu. Okay, so this is a solution for question number this is 5D. So in the next video we will see out the part E of this question number 5.